PeopleSense Industrial Personnel Classifier is an embedded AI computer vision system offered by Global Networks' Team Calico. This system provides an IoT solution for human presence sensing and classification in industrial safety and management environments. The system is a software application running on the Renesas RZ-G1M system on module integrated into an iWave Q7 development board. This video describes and demonstrates Global Networks' PeopleSense Computer Vision Industrial Personnel Classifier. The use case targeted for the PeopleSense CV Industrial Personnel Classifier would be that of a construction site or an industrial factory floor. Human presence would be detected using machine vision and classification based on real-time processing of video through a convolutional neural network model, in this case, Google's SSD MobileNet version 2. From that point, classification of personnel based on safety vest color would be performed, where we would identify unauthorized persons by the absence of a safety vest. Local's PeopleSense CV Industrial Personnel Classifier utilizes Google's single-shot detector MobileNet version 2 for detection and classification of human presence. Google has open-sourced this model. The MobileNet models are small and accurate for object detection and recognition, ideal for inference use cases on mobile devices and embedded platforms. The addition of the single-shot multi-box detector are additional model layers added to the MobileNet base model to provide object detection and localization in a single pass. MobileNet version 2 requires 300 million multiply accumulate numerical operations per frame using 3.47 million parameters. The simplified processing flow for the personnel classifier, which is a Python 2.7 application, is as follows. A video feed is streamed from a remote source to the iWave Q7 board using a webcam running on a VLC server. Frames are then captured from the remote video source and pre-processed by the application using OpenCV 3.0. Pre-processed frames are then processed by the SSD MobileNet model running on TensorFlow for localization of humans within each frame. Color segmentation is performed by determining the size of the color mass above a threshold value inside of each box detection containing a human. This is done by OpenCV 3.0. Classification of personnel, whether they're a worker or a supervisor, results from a determination of the above threshold pixel count for either an enraged red or green color mass within the HSV color space. This slide represents the machine vision processing pipeline utilized by the personnel classifier application. Video input is presented to the application frame by frame, where frame capture is performed by OpenCV. Each frame then serves as input to a TensorFlow session. Feature extraction and object recognition is then performed using the SSD MobileNet model. Single-shot detection allows for localization of objects within the frames. Here, box coordinates are returned containing human objects. A region of interest is then defined by these box coordinates containing human objects. Within these regions of interest, color segmentation is then performed by OpenCV. Digital color masks are used in order to segment the colors within these regions of interest. This is used to identify the vest class by color: green for a worker, red for a supervisor. Bitwise operations with these color masks allow for the determination of the count of red or green pixels within the region of interest. This allows classification of the vest class. The PeopleSense CV personnel classifier architecture. Essentially, the application is a Python 2.7 program running on the iWave Q7 development board. The application utilizes the SSD MobileNet model, which is running on TensorFlow or processed through TensorFlow. Additionally, integration of the best color classifier is done by OpenCV 3.0. All imported into the application into the Python 2.7 application. In order to effectively develop and run the PeopleSense CV industrial personnel classifier, we had to create a modified embedded AI-ready board support package from the existing iWave Q7 RZ-G1M board support package provided by iWave. In this case, we used the base IG21M release BSP build that was provided by iWave, and this was based on Yocto 1.6, Yocto Daisy. We then modified the IG21M release BSP by adding development tools from the Build Essentials package. We additionally modified the IG21M release BSP by introducing a recipe and patch source for building OpenCV 3.0. The final modification was an as-built IG21M release BSP modification performed by an onboard Python pip install of TensorFlow 1.9 from an existing wheel package. This install provides TensorFlow 1.9 binary with Python support. Details of the industrial personnel classifier application are given in this slide. The classifier is a Python 2.7 application running on embedded Linux kernel 3.10. The embedded Linux is a Yocto 1.6 build. The Python application integrates OpenCV 3.0 and TensorFlow 1.9 support. In order to run the personnel classifier application, the Global Networks embedded AI-ready RZ-G21M board support package based on a modified iWave IWG 32M release BSP build is required. The personnel classifier's core object detection module and TensorFlow integration is based on an application published by DatTran. The core object detector was adapted and integrated with the VEST classifier module for performing safety VEST color segmentation using OpenCV. The personnel classifier application runs an object detector TensorFlow session with a configurable number of processes using Python's multiprocessing library. It was found that optimum process deployment was one main Python process running in parallel with 3 TensorFlow object detection session processes. This effectively utilized one application process per core. Essentially, frames are deployed to parallel TensorFlow sessions, each running a separate instance of the SSD MobileNet model. In this video, we see an actual demonstration of the PeopleSense CV industrial personnel classifier running directly on the iWave Q7 development board. In this case, we see human presence detection performed by the SSD MobileNet model on TensorFlow. Subsequent classification based on vest color is performed by color segmentation using OpenCV 3.0. Workers are wearing a green vest. Supervisors are wearing a red vest. An unauthorized personnel does not have a safety vest on. The actual frame rate running on the iWave Q7 board is about 1.2 frames per second.